students. This week, we are going to be exploring more of the animal kingdom as we focus on the vertebrates. And last week, if you recall, we learned about the invertebrates, and hopefully you remember that invertebrates don't have a backbone, but as you can imagine, vertebrates do, but they also have other things as well. So let's get busy now and begin our topic on vertebrates. So be sure to open your books as we begin to take our notes on the topic of vertebrates. Perhaps you have watched the video already and about vertebrates, so you've already gotten a little bit of an introduction to our topic this week, but let's explore it in a little bit more detail at this time. First of all, we are going to be exploring a particular phylum. Remember, part of the taxonomic classification system. Kingdom is the biggest grouping. Phylum is a subgroup of kingdoms. So we're all under the animal kingdom. And the phylum we're going to be exploring this week is Phylum Chordata. If you look at this picture here, you will notice that all of these are living creatures, but some of them are grayed out and some of them are in full living color. And if you look at the ones that are in full living color, you will see that they all have something in common with one another, in contrast to the ones that are grayed out. So look at this picture here and see if you can notice what all of these things that are in full living color have in common with one another. Any idea? They all have backbones. They all are vertebrates. They are all members of Phylum Chordata. Now, we're going to be exploring this phylum, including all of these little cute critters that we see here. But as we do, we have to keep in mind what are the vertebrates as various classes of animals. So these are the groups that we're going to be exploring over the next couple weeks. The fish, amphibians, reptiles, birds, and mammals are all members of Phylum Chordata. So do you see us there? Yeah. Mammals, human beings are mammals. We are in this Phylum Chordata. Now, we're going to be talking about us more uniquely and in a more special way because we are so special later on. So we're not going to focus on mammals and humans this week, but we'll be getting to us soon enough. We save the best for last. But we are going to be exploring this week the fish, amphibians, reptiles, and birds. So we're going to be taking a whirlwind tour of Phylum Chordata starting today. So to begin, let us first discuss what is a vertebrate, because Phylum Chordata includes all vertebrates, and a vertebrate is an animal that has a backbone. We all have backbones, and if we were to look at the picture of the skeleton here and turn it around and rip out our backbone, ooh, golly, we wouldn't want to do that. This is what our backbone looks like as a human being. But other vertebrates also have backbones. Here's a fish's backbone. And here is, golly, I don't even know what this is. Some kind of an interesting looking critter. But there's its backbone. A frog has a backbone. All vertebrates have backbones, which is more technically termed a vertebral column. Vertebral, adjective form of the word vertebrate. So all chordates, or members of Phylum Chordata, include vertebrates, which are animals that have a backbone. Now, there are 4 general characteristics that biologists use to distinguish between chordates and other types of animals. So we're going to go over a list of 4 things. And I want to emphasize something important as we go over this list. These 4 characteristics of all chordates, I have in parentheses written here, at some point in their development. And that's a really important point, because as we go through this list and we remember the fact that we are members of Phylum Chordata, you're going to be questioning, hey, wait a minute, what is up with that characteristic? I don't have that, and I'm a chordate. Well, at some point in our development, we did. You'll understand exactly what I'm talking about in just a couple of minutes. So here we have some pictures of embryos. Embryos, as you may recall, are developing fertilized eggs. And so here we have some examples of fish, chicken, pig, and human in embryonic stages. When we're really, really tiny, developing in our mother's womb, we look different at some points than at other points. In fact, when we were very, very young, at one point, this is what we looked like. I know, it looks like we are lizard people or something like that. But when you are first conceived, the human embryo looks different than a full-grown human being. But notice, a pig embryo. Now, I know some of you may know people who eat like pigs, but they are not pigs, right? Look at these diagrams of our embryos. Do you see the similarities that exist between the embryonic stages? Not adult stages, but embryonic stages. Also notice the embryo of the chicken and the embryo of the fish. All of these are chordates, and notice the evident similarities that exist between them. I'm not saying they're all the same, don't get me wrong, but you can see that there are some similarities. So here we go. Characteristic number 1. The first characteristic that all chordates share is that they possess a nerve cord. If you look at this generalized diagram here, you can see the location of the nerve cord, which is on the dorsal side, and dorsal is a word that simply means the back of something. So the nerve cord of chordates is on the dorsal side of the animal. So nerve cord, first characteristic. Second characteristic is a notochord. Notice the difference in spelling here of cord. But a notochord is a flexible support rod. Now, in the case of a human being, our notochord is our vertebral column, our spine, in other words. Our backbone is our notochord. And inside of our backbone is our spinal cord, our nerve cord. So right off the bat, we can see that we fulfill these 2 characteristics as humans, belonging to the group of mammals of vertebrates. But we can easily determine that humans have a nerve cord, our spinal cord, and a notochord, our backbone. Easy peasy, right? Now let's check out the third and fourth characteristics. The third characteristic is that at some point in embryonic development, chordates all evidently have pharyngeal slits. Now, what are pharyngeal slits? Well, pharyngeal. The pharynx of humans is our throat. Our throat is our pharynx. Maybe you've heard of laryngitis. Laryngitis is inside your pharynx. Your pharynx is your throat. Anyway, pharyngeal slits. Now, with some chordates, they grow up and they develop gill slits, like fish have gill slits. We don't have gill slits. Now, there was a science fiction movie a number of years ago called Waterworld with Kevin Costner, and it was rather a very bad movie. I wouldn't necessarily advise watching it. It was a pretty poor movie, not one of Kevin Costner's better movies. But in that movie, he portrayed a futuristic human that developed gill slits on his neck, which enabled him to breathe under the water, which, would be kind of cool if you think about it. But we don't have gill slits. So why is this one of the characteristics? Well, it's because, like I showed you in that diagram earlier of the embryonic development of even mammals at an early stage of embryonic development, we actually do have pharyngeal slits that in some animals develop into the gills, like on fish. With us, our pharyngeal slits eventually develop into our ears. So we've got ears, not gills. So keep that in mind. But at some point in our development, we did appear to have pharyngeal slits. Now, the next one I think you're really going to like. The fourth characteristic, all chordates have tails. No. Not really tails, but tail bones. And the word there, postanal, is not a derogatory description of a tail. It is the description of location. On this diagram, if we look here is the anus, which is the end of the digestive system. And all chordates have an anus because they have a digestive system that empties out in some location, and that location simply is called the anus. The word post does not refer to like a fence post. Ouch, that would be bad. But post in biology refers to a position or a location that is toward the back of something. So postanal simply refers to the location of tailbones. Now in this diagram here are the tailbones, and they are postanal, which means they are beyond the end of the digestive system. You and I, as human beings, we also have tailbones. If you look at a diagram, and I'm just zooming into this previous diagram so you can see where I'm talking about here. So here's the digestive system. Here's where the digestive system ends. It's called the anus. And here is the postanal tail, which is part of the backbone, essentially. And all chordates have postanal tail bones. Again, that doesn't mean all chordates have tails. We certainly don't have tails, but we do have a tailbone. I know this for a fact because when I was younger, I did something very foolish. And I'm almost embarrassed to admit it to you. But when I was younger, I used to spend a lot of time in the woods, and I would hike around and play around and climb trees and also swing on vines. Now, please take my advice and don't ever swing on vines hanging down from trees. I'm about to tell you why. Because there was this one day where I was hiking through the woods and there was this pretty deep ravine. Oh, I don't know, about an 8-foot deep ravine, a dried stream bed. And there were trees on both sides of this ravine and there were vines hanging down. I thought, hey, wouldn't it be cool if I swung across this ravine, swinging on a vine? And so I pulled on some vines. I found one. And by the way, many of those vines in our region of the country that are hanging down from trees, do you know what they are? Many of them are, not all of them, but many of them are poison oak vines. Another reason not to swing from vines. But that's another story. So I grabbed onto one of these vines, thought it was strong enough to support my weight. I grab a hold of it, jump up, and whee! I start swinging across the ravine. Unfortunately, the vine was not strong enough to support me. And so the vine snapped. And I went flying about 8 feet down into a pile of rocks on my back and hiney. And guess what happened? Among other things, like knocking myself out and tearing all the muscles in my back, I also broke my tailbone. And let me tell you something. I never knew I had a tailbone before that happened, but I can guarantee you I felt my broken tailbone that day. I even have x-rays to prove it. Maybe I'll show them to you one day. But we all have tailbones. It doesn't mean we have tails. Now, with some species, like, say, cats or dogs, those tailbones extend much further and do develop into actual tails. But all chordates do have tail bones. Now, I mentioned some differences, right? We just went over some characteristics of similarities, but there are also some differences. In fact, scientists have classified chordates into 8 distinct groups. 5 of those groups, or rather, I'm sorry, 5 groups. 5 groups. There are 5 groups. I misspoke, not 8. There are 5 groups of chordates. And those 5 groups are called the classes, and they include fish, amphibians, reptiles, birds, and mammals. And I mentioned those earlier in this lesson. But today we're going to focus on some general differences between those 5 groups. You see, 3 of them are called ectotherms, and 2 of them are called endotherms. But let's focus on the characteristics of ectotherms first. So let's look at the word itself. Ectotherm. What in the world is an ectotherm? Well, let's dissect the word and find out. You know what ectotherms are, undoubtedly, but you may have known them by a different name. So let's look at this word ectotherm. The prefix ecto simply means the outside of something. We get other words that sound like ecto, which come from the same Greek root word, like exo. An exoskeleton, we've mentioned in the past, that outside hard covering on bugs, insects, for instance. The word exit on the lab door, above the lab door, or in public buildings, you follow the word exit to get out of something. These all have something in common. The word means outside. So ecto means outside. What about therm? And you think for a moment about the suffix therm and think about what that word means. And while you're thinking about it, let's think of other words that have therm in it. Can you name any? Maybe thermometer, thermostat, thermos, thermal underwear. You can probably think of others as well, but what do all of those relate to? They all have something to do with temperature or heat energy. In fact, therm simply refers to temperature. A Thermometer is a device used to measure temperature. In fact, we're very common with digital thermometers this year because you get scanned for your temperature every morning. Thermometer measures your temperature. So the word ectotherm literally means outside temperature. Big whoop-de-doo. What does that actually mean? Well, it has to do with the way in which an animal's body temperature is regulated. Ectotherms are also known as cold-blooded organisms. But that word cold-blooded is not really a scientifically accurate term, so we're not going to use it. But that's probably what you have heard them being referred to as before. So what are cold-blooded organisms or ectotherms? These organisms are those that have their body temperature regulated by the temperature outside their body. They do not have the ability to regulate their internal body temperature internally like we do. That's why we take our temperature every morning, because our bodies are constantly trying to maintain a constant body temperature. Ectotherms are not like that. In fact, if we were ectotherms at this point in history and every morning they're scanning your temperature, it would come up different every morning based on what the air temperature outside your body was. It would not be a very accurate measure of whether you were sick or not. So ectotherms, outside temperature, also known as cold-blooded critters, their body temperature is regulated by the outside temperature. Now, why did this word cold-blooded come to be popularly used? Well, it's because, really, I don't know. But, if the temperature is lower than it normally would be for our body temperature, say take a turtle's temperature, although it might be difficult to put a thermometer in a turtle's mouth. But if you took the temperature of a turtle, let's say, it's going to be significantly lower than human body temperature, and that's okay. Their body temperatures fluctuate based on the outside temperature, even if it's colder than our body temperature. So ectotherms is the name. And so let me give you some examples of ectotherms. Fish are an example of an ectotherm. Their body temperature is regulated external to their body itself. Amphibians are also examples of ectotherms. Those cute little froggies and salamanders are examples of amphibians. And finally, reptiles. Reptiles are also examples of ectotherms, which is why this time of year, and right now it's winter time here, you're not going to see any, you really don't see any ectotherms roaming around. Of course, fish are going to be swimming down deeper in the water, not in the ice, or they'll be in your freezer. But amphibians and reptiles, you're not going to see them this time of year. Amphibians are burrowed under the mud where it's a bit warmer, and reptiles are buried in holes under the ground. You're not going to see them out this time of year because their bodies would freeze, because they cannot maintain a constant body temperature. Now, there are also, as I said, two groups of endotherms. And the endotherms, if we look at the word itself, let's think of some characteristics of that term. If ecto meant outside, what do you think endo means? Yeah, inside. So the prefix endo means inside, and therm, it still means temperature. So an endotherm, just looking at the word, means inside temperature. And you can probably guess that endotherms are also known as warm-blooded organisms, although we're not going to use that term because it's not necessarily accurate scientifically. The important part is that the body temperature of endotherms is regulated internally. That's why doctors and health professionals can take your temperature and determine if you're healthy or not, because again, as I said earlier, your body as an endothermic organism is always trying to maintain or regulate a constant body temperature internally. So if you wanted to be a veterinarian one day, you might work with horses or dogs or cats or cows, and you would learn the different internal body temperatures of different endotherms because they do vary from one species to another. The human internal body temperature on average is 37 degrees Celsius, or probably more familiar to you, 98.6 degrees Fahrenheit. In either case, we regulate our temperature internally. And so I want to continue and finish up today with a couple of examples of endotherms. Birds are endotherms. That's why if you've ever seen pictures of penguins down at the South Pole, penguins, it's cold down there, folks. So what do penguins do to help one another stay warm? Well, when it's really cold, they all gather together in a group so that they can share their internal body temperature with others of their group so that they don't freeze to death, which would be, well, really bad. It's also, the other group are the mammals. Mammals, including people, we are also endotherms. Next week, we'll be exploring mammals specifically, and then in the following weeks, we'll be focusing on humans. But this week, we'll be focusing on the birds and as endotherms and all of the other groups of ectotherms. So we're going to end this here for today, and tomorrow we'll pick up with our first group of ectotherms, the fishies, the fish. So until then, bye-bye.